relationship between the roots and the coefficient of a quadratic equation, right? So if alpha and beta are the roots of the general quadratic equation, then if you want sum of root means adding. It can be compared to you saying minus b over a. So alpha plus beta is tantamount or equal to minus b over a. So when you don't have alpha, you don't have beta. Yes, minus b over a here can be your sum of roots. Product of roots. If you don't have alpha, you don't have beta. When you compare, divide the c over a, it can be your product of roots, right? So there is a relationship linking them. So all sum of roots is minus b over a. It will give you sum of root, right? This is product of roots. Now these are some parameters that we have to look at. Now why have I circled this one? The first formula you see is universal, right? In which sense? It means the first formula is seen in most of those parameters, or the basis for deriving most of these parameters. Now the ones have asterisks in blue. It means they can be derived directly. Now the ones without asterisks, you look at this. So where on earth do you think alpha minus beta can produce this? Can't you see that certain mathematical concepts have been employed just to get this? From calculus to anything. So it's not just direct, right? So alpha minus beta, you need to know this. Right? We are not here to prove this formula. Good. Unless you want to prove. So alpha squared, beta squared can be obtained. That's the difference of two squares. Can you see? Now, alpha cubed plus beta cubed. This is what I'm going to get. Okay, so make the work very easy for you. The ones of asterisks can be obtained directly, right? You can manage that. You are supposed to know this at all costs, right? Second order. So take note. So you can manage the 4. This can also be obtained directly. Let's see. Look at this one. I can have 1 over alpha plus 1 over beta. You see, LCM was obtained here. This goes here beta. This goes here alpha. That is why I have alpha plus beta over alpha beta. So what you do is that the ones which can be obtained exactly, you don't pay much attention to them, right? Pay attention to the ones that have no asterisks. So this one is when it comes critical, you can obtain them, right? Now there is also concept of LCM. Let's see. 1 over alpha squared plus 1 over beta squared. So I have alpha squared, beta squared my LCM. Do you agree? Now this goes here, I'll get beta squared. This is alpha squared. And this alpha squared plus beta squared, all about alpha, beta, all squared. Do you agree? Now alpha squared plus beta squared. I told you this second one, universal, right? So it's here. So what do you see there? At the top here, at the top, you see alpha plus beta. I'm trying to expand this, right? Minus what? 2 alpha beta. Good. Minus 2 alpha beta. So all over what? This, as you can see. So I've obtained it. So you really have to know the number 1 is very important, okay? We look at it. There's something positive, you have a negative on the right hand side. So it's not a direct thing as you see, right? Now the next one. Okay. This can also be obtained. Let's see that. Alpha minus beta all squared. We have a perfect square expansion, right? Do you remember? So alpha by alpha is alpha squared, agree? Alpha by beta is what? Alpha beta. Alpha by beta, alpha beta. This by this is also what? Alpha beta. Negative beta, positive beta what? Squared. Are you okay? So this and this, I can group them alpha squared plus beta squared. That is 1, right? So this will give you minus 2 alpha what beta. Now this alone will have that expansion you see there. Alpha plus beta all squared minus 2 alpha beta minus another 2 alpha beta. Now alpha plus beta all squared minus 4 alpha beta. Wow. I think that is what you see here. So do you see? Now that is how best I can help you. Number 1 circle is universal, no rate of head. The ones of us there, don't pay attention to because they can be derived. Right? And the ones without asterisks, You need to know them, right? Now let's continue with our work. So I've explained that. So what we are doing, right? Alpha and beta are roots of the equation 4x squared minus 20x plus 15 equals 0. Find the value of alpha squared beta squared. That is formula number 1. Alpha squared beta squared, right? Now, watch here. So there is a perfect square expansion as we proved. We had this. If you look at number 3, I think it's not bad. The 2 is linking 3. In which sense? It's when you have x squared equals 4. This forms a root of this. Remember the principle, right? Before you get plus or minus the answer. So that's what we are seeing here. See, this square forms a root of that. So I think if you know 2, you should be able to get over 3. So the problem has gone down. So we just have 3 indirect ones that you have to contend with, right? So look at it. When you throw the square on this, it forms a root here. So 2 is linked to 3, right? So let's look at our question. Alpha and beta. So I have the equation 4x squared minus 20x plus 15 equals 0. Now I'll compare to the general quadratic equation, right? Compare to ax squared plus bx plus c equals 0. Implication: a happens to be 4, b is negative 20, and c is 15. Good, that's what we are seeing here. Now, sum of roots, as you said, sum of roots is alpha plus beta, what is equivalent to what? Negative b over a. So, I feel like using alpha plus beta to get my sum of roots. If you look at the question given, I don't have my alpha, I don't have my beta. So I cannot physically write alpha beta as sum of roots. So if this is not working for me, I'll be choosing this. Are you okay? So I will go for negative b as negative this. Please don't forget your minus, right? All over what? This. So we are going to get 5. That is 20 over 4, right? 20 over 4. You get 5. What's the 5?
Why isn't it negative?
Now, the formula is negative b over a. So there's a negative you see here. And the b also happens to be negative. That is it, right? Good. So I'm going to get positive 20 over 5. Are you okay? Good. Now, product of roots. Product of roots. We have alpha beta. What is equivalent to what? C over a. You remember? So c is 15 over 4. Good. I've been asked to find alpha square plus beta square. What will I do? Alpha squared plus beta squared is given by alpha plus beta all squared minus 2 alpha beta. Now alpha plus beta all squared, you check here, alpha plus beta, there is it 5. Minus 2 alpha beta. Yes, alpha beta is equivalent to this. So that is that, okay? So this will give me 25 minus what? 30 over 4. Now what will it give you finally? 25 minus 30 over 4. And you get the answer from there. 35 over 2, right? Good. Let's go. So let alpha beta be the roots of the quadratic equation. That's what you see here. Without solving this equation, don't try to solve this and get the roots. Maybe x equals minus 1 or x minus 2. No. Evaluate this. So I'll compare to the general quadratic equation, right? Compare to ax squared plus bx plus c equals 0. Now a happens to be 1. You agree? B is 2 and c is negative 5. Now I'll come sum of roots. That is alpha plus beta. It's the same as minus b over what? A. So there is 2 over what? 1. That will give me what? 2. Minus 2 over 1. That will give you minus what? 2. Thank you. Product of roots. Product of roots. Alpha beta. That is equivalent to c over a. That will give us minus 5 over what? 1. That will give me minus what? 5. Evaluate alpha squared plus beta squared. Alpha squared, beta squared. So that is alpha plus beta all squared minus 2 alpha beta. I hope you remember expansion number 1, the one I circled. Good. Now this is this. This is that. So this will give me 4 plus 10. The final answer will produce 14. Please, I hope you are seeing it. Good. Now, let's go to what we call, okay, that's it. Half alpha to beta, so that's all. Now, evaluate alpha minus beta all squared. Evaluate alpha minus beta all squared, right? Alpha minus beta all squared. So that is what? Alpha plus beta minus 4 alpha beta. Yeah. Or it can be derived. You know that, right? Open perfect square expansion and derived. Now alpha plus beta all squared. Let's go here. That is minus 2 here. And then, yeah, okay. That's minus 2. 4 alpha beta minus 5. So this is 4 plus 20. That will give me what? 24. Good. Now, obtain a quadratic equation whose roots are these. Wow, they give me a new root. Obtain your equation, right? So you see, I have a sum of roots here. And they're giving you another root. So you just cannot go by saying sum of root again. No. Not to qualify. Sum of new roots. Because that's a new root, right? So that it will not contradict our sum of root. Because we have another sum of root already. Okay? So I have these roots. Alpha squared plus 1, beta squared plus 1. So I have sum of new roots. So let's go. I have alpha squared plus 1 plus beta squared plus 1. Do you agree? Yeah. So this and this is alpha squared plus beta squared plus 2. Agree? Good. Now alpha squared plus beta squared. You have to go through this expansion, right? Or better still, you write just 14. It's accepted, right? Okay. Because we have 14 after solving it, right? Or you expand again and still get a 14. Plus 2. So that will produce what? 16. Now, product of new roots. Are you okay? Why do I say new? I have an old root. So product of new roots. Product of new roots. That is alpha squared plus 1 all times beta squared plus 1. So you have to do some expansion here, right? Okay, expansion. This and this will give me alpha squared, beta squared. Agree? This by this will give me what? Alpha squared, beta squared plus 1. Good. Now I can put them together here and get this. Agreed? Then I'll get alpha squared plus beta squared plus 1. Okay. I think I need to continue from here. Okay, so here, alpha beta all squared. This from here. Alpha beta all squared, right? That is it, right? Minus 5 squared. Alpha squared, beta squared. 14 plus 1. So this will give me 25 plus 15. What's the final answer? 40. Right? Now what are they asking me to do? They are asking me to write an equation. So obtain a quadratic equation whose roots are this, right? So there's my equation. S squared minus sum of roots all x plus product of roots all equal to what? 0. S squared minus sum of roots. So I'll be using the new roots, okay? That is 16 with an x. Product of roots 40 equals what? 0. Good. That is the question. So you should understand when we use new roots. But there are some old roots there, right? Okay. Now that is the end of the topic called quadratic functions in further mathematics, right? Okay, so we have some assignments at the end of the video. Take your time and go through the assignments and let us know or let us in the comment section, right? Please always remember to visit the playlist, right? When you go to our channel, please go to our playlist. We've arranged all the topics categorically. Thank you.